and subtracting radical expressions. So the easiest way to explain this is to say that you treat the radicals like variables. Okay, you treat the radicals like variables. You can only combine these terms if they have the same square root or cube root or whatever root expression. But unlike variables, we just finished simplifying these things, we can usually rewrite these so that they may end up being the same expression under the radicals. So let's look at this first example. Negative 3 square root of 6. Is 6 divisible by a perfect square? No, there's nothing we can do with that one. There are two ways that we can handle this problem. We do have two like terms right now. We could go ahead and combine those. Let's do that. Let's go ahead and put those square roots together. So we have 2 square roots of 24 minus 1 square root of 24. So that means overall we have a positive 1 square root of 24. Now, can we simplify the square root of 24? Yes, we can. Okay, it's divisible by 4. No, because I have 2 of them here and I only have 1 of them here. So 24 is 4 times 6. So the square root of 4 is 2. So that's 2 square roots of 6 is how we rewrite the square root of 24. Now they both have a square root of 6, so we can combine their coefficients. So that is equal to the negative square root of 6. Now, you can use your calculator to confirm. You can't really use it to give you the answer because when you type this in, it will give you an answer, but it's going to be in decimal form, and the answer that I'm looking for needs to be in square root form. Okay, now be careful when you're typing it in. Make sure you close your parentheses at the end of every square root, but we can confirm whether or not that is equal to the negative square root of 6. Now, again, if you go to check it, it does not guarantee that you have the absolute simplest answer. Because if I had typed in negative 3 square root of 6 plus the square root of 24, guess what I would have also gotten? The exact same decimal. But this answer right here is not fully simplified. It's equivalent to the other two, but it's not in the in the most simplified version. Okay, so keep that in mind. It's a good thing to check, but it doesn't guarantee that you have the simplest answer. Okay, let's look at example B. Negative 3 square roots of 5. Can we simplify that square root? No, so we just bring it down. Square root of 27. 27 is 9 times 3, so the square root of 9 is 3. So that's 3 square roots of 3. 12 is 4 times 3. The square root of 4 is 2. We multiply it by the 3 in front. So we get 6 square roots of 3. So we can combine these two. We cannot combine them all, but we can combine the two that have the square root of 3. We've got negative 3 of them plus 6. So overall we have plus 3 square roots of 3, in addition to the negative 3 square roots of 5. Do y'all need me to write out more work, or are we okay with what I'm writing? Yes, ma'am. It doesn't cancel. It's kind of like if we have this, negative 3x plus 6x, what's the answer? 3x, right? So we're doing the same thing here. They have the same square root, so we just add their coefficients in front. So negative 3 plus 6 is 3. Which part are you asking me about? Does that make sense? Okay. Okay, we can do this with cube roots as well. We just need to simplify the cube roots instead of square roots. So let's see here. Perfect cube that goes into 125. Oh, guess what? 125 is a perfect cube. 125 is 5 cubed. Yes, ma'am. I'm sorry. I didn't multiply 4 times 3. Okay, 4 times 3 is 12. The square root of 4 is 2. Yes, ma'am. Oh, yes, we could go ahead. I'm sorry, I had tunnel vision on the cube root of 125. Yes, you can go ahead. You can do it either way. Okay, good point. All right, so the way that I'm going to continue going the way that I was going, and then I'll show you what Aaliyah is talking about here. Okay, so 2 times 5 plus 2 times 5 plus 3 times, let's see here, 81 is divisible by 27. Cube root of 27 is 3. 3 times 27 is 81. So that's 3 cube roots of 3. I lost my cube root there. So we've got 10 plus 10, which is 20, plus 9 cube roots of 3. That's one way to get to the answer. Another way to get to the answer, Aaliyah asked, can we not just go ahead and combine those? We most certainly can. 4 cube roots of 125 plus 3 cube roots of, I don't care how you write it, however you need to simplify it. But that's 4 times 5. Well, guess what? That's also 20. Okay, so it doesn't matter whether you combine them first or whether you start to simplify them first, you still get to the same conclusion. Yes, sir? Can you combine 20 and 9? No, you can't, because the 9 is attached to the cube root. Multiplication and division comes before addition and subtraction. Good question, because somebody does that every single time anyways. So thank you for bringing that up. This is multiplication right here. Between the 9 and the cube root of 3, that's multiplication. Order of operations says you multiply before you add and subtract. So you cannot combine that 20 and the 9. Okay? That is as far as you can go with it. And again, if you have a question about it, just type it into your calculator to check. Okay, 2 cube roots, this one will take me a minute, cube root of 125 plus, whoops, forgot to close my parentheses. That would not be good. 2 cube root 125 plus 3 cube root 81. Okay, my answer is 20 plus 9 cube root of 3. That gives me the same decimal, but if my question is, can I add those? Is that the same as 29 cube roots of 3? Just type it in. It's not the same number, so no, it's not. No, I can't. Okay? All right, so